Welcome to Tech Blueprint, a window that lets you know the latest technology news in the world. Recently, a digital blogger revealed that the Kirin 9030 chip has undergone a major upgrade. Its GPU surpasses the Kirin 9000 in every respect. Combined with the CPU upgrade, it is undoubtedly the pinnacle of Kirin history. What is the performance of the Kirin 9030? Which generation of Qualcomm Snapdragon is it equivalent to? The Kirin 9030 will debut in the Huawei Mate 80 series and is expected to be released in October of this year. Process: utilizing SMIC's 7nm N+3 process, the transistor density has increased to 120 million per square millimeter, approaching the international 5nm level. CPU: utilizing the new Taishan architecture, it features 8 cores, including 1 super core plus 3 large cores plus 4 small cores, and supports 12 threads, resulting in an overall performance improvement of 30% to 40% compared to the previous generation. The GPU has also seen significant improvements, utilizing the next-generation Male-Noon architecture and GPU turbo technology. Graphics processing performance has increased by 60%, significantly improving the gaming experience. In terms of benchmark scores, Antutu's benchmark score is expected to reach 1.4 million to 1.5 million, a significant improvement over the previous generation Kirin 9020's score of 1.24 million. The Kirin 9030's overall performance lies between the Snapdragon 8 Gen 2 and 8 Gen 3. The Kirin 9030 is considered the most powerful Kirin chip ever. This is due in part to its meticulously crafted manufacturing process. While lacking EUV lithography, the immersion DUV lithography machine, coupled with hundreds of adjustments to etching parameters, has increased transistor density to 120 million, surpassing Samsung's 5nm process. Another aspect is the GPU upgrade. For gamers, the GPU is like the engine in the game. Insufficient power can impact the overall experience. Coupled with the advancements in AI capabilities in mobile phones, the importance of the GPU is clear. The 2023 Kirin 9000's GPU uses Huawei's self-developed Mali 910 processor, clocked at 750 MHz. Its overall performance is slightly lower than the Mali G78 in the previous generation Kirin 9000. The 2024 Kirin 9010 didn't even receive a GPU upgrade, and it wasn't until the 9020 model that it was upgraded to the Kirin 920, with a frequency increase to 840 MHz. In other words, Kirin chips have been relatively lacking in GPU upgrades over the past few years, while mobile gaming and AI have been developing rapidly. This is the main reason for the insufficient performance of mobile chip performance. As for the CPU, it is primarily responsible for performing various daily computing tasks, including running the operating system, running apps, and computing user input. Compared to mobile gaming and AI, this usage hasn't increased much, and coupled with the long-term oversupply of CPU performance, the impact is relatively minor. So, as long as the Kirin 9030 incorporates innovative GPU technology and achieves a significant upgrade, this chip will run very smoothly and significantly reduce heat generation. Why do consumers value Kirin chips so much? Honestly, the Kirin chip lags behind Apple's A series, Qualcomm Snapdragon, and MediaTek's Dimensity in terms of performance. It's even inferior to Xiaomi's Xuanjie 01 based on specs alone. So why are people still so excited about the Kirin chip? The most important reason is, the Kirin chip is a truly domestically produced chip. Looking back at the Kirin chip, 20 years of hard work have finally forged the foundation of a Chinese chip. The establishment of Huawei HiSilicon in October 2004 marked Huawei's official entry into the chip industry. However, at the time, it primarily developed switch and router chips. As Huawei's presence in the mobile phone market deepened, Ren Zhengfei proposed allocating 2.4 billion yuan to HiSilicon to develop its own chips. After several years of hard work, Huawei's first mobile phone chip, the K3V1, was released in 2009. However, due to its significantly inferior process technology to that of overseas chips, it was rejected by the market. The second model, the K3V2, was also rejected by the market due to its overheating. Later, Huawei realized that it needed to pursue an integrated approach, integrating the CPU, GPU, and baseband into a single package to elevate mobile chip designs to new heights. In December 2013, the Kirin 910 was released. This chip not only integrated the Balong 710 4G baseband, but was also Huawei's first mobile chip to bear the Kirin name. Utilizing TSMC's 28nm process, the Kirin 910 featured a quad-core CPU, a Mali 450 GPU, and an integrated 4G baseband, which helped the chip gain market acceptance. The Kirin 990, however, was the true highlight of the Kirin chip market. Featuring TSMC's 7nm process, an octa-core CPU, a 10-core GPU, and its own DaVinci NPU, it achieved peak power consumption and performance. Most importantly, it was the world's first 5G SoC. At the same time, Qualcomm's Snapdragon 865 and Apple's A13 still used external basebands. It can be said that, with fair use of global resources, Huawei's Kirin chips have surpassed both Apple and Qualcomm. With Huawei's inclusion on the Entity List, it lost access to Western components and TSMC's foundry services, leading to a generational gap in the Kirin chip market. But it was precisely these suppressions and restrictions that led to the true independence of Kirin chips. Starting with the Kirin 9000S, the CPU architecture adopted the in-house Taishanliang architecture. The GPU was also replaced with the in-house Maliang architecture, and the foundry was shifted to a mainland Chinese fab. With the Kirin 9020, all CPU and GPU cores were independently developed, completely abandoning the ARM public architecture. Combined with an in-house developed 5G baseband and domestic foundry services, the company's independence rate is close to 100%. The significance of independence and control lies in the security of data, information, and privacy. More importantly, it ensures that even if the competition escalates, China will not be left without chips. This is why consumers value Kirin chips. Even this chip is slightly inferior in terms of craftsmanship and performance compared to the latest Apple A series, Qualcomm Snapdragon, and MediaTek Dimensity. However, Huawei's unique preference for domestically produced chips has made Kirin-powered phones a hot seller. The next step remains to upgrade the core performance of the chips. With localization already meeting the standards, the next step is to upgrade and iterate to further enhance performance. The biggest challenge facing Kirin chips currently lies in manufacturing. Huawei is already capable of designing a 3nm mobile SoC, but the manufacturing process doesn't meet the requirements, forcing them to settle for second best. The fundamental reason domestic wafer foundries can't iterate to 4nm and 3nm is a lack of EUV lithography machines, not a lack of manufacturing technology. EUV lithography machines are monopolized by ASML of the Netherlands. Due to the Wassenaar Treaty and the export restrictions on semiconductor equipment from the United States, Japan, and the Netherlands, domestic companies simply cannot purchase them, forcing them to develop their own. The development of 100,000 precision components, over 4,000 precision bearings, and over 3,000 cables is extremely challenging. ASML has integrated global expertise to complete the EUV lithography machine. Now, China must independently develop EUV lithography machines, taking on this mission impossible. Once China develops its own EUV lithography machines, Kirin chips will undergo a major upgrade and be produced in large quantities. Huawei's smartphone prices will then be appropriately reduced, providing a boost to domestic consumers.